Coal is a fossil fuel extracted from the ground by underground mining or open pit mining, that is surface mining. It is a readily combustible black or brownish black sedimentary rock. It is composed primarily of carbon along with assorted other elements including sulfur. Often associated with the Industrial Revolution, coal remains an enormously important fuel and is the largest single source of electricity worldwide. Coal is the main source of energy not only in our country but also for most of the countries of the world. The energy requirement of India is increasing every year, and to meet this demand the country has to depend to a large extent on coal. At present, more than 60% of the total commercial energy requirement is met from the coal. India has the 5th largest coal reserves in the world. Of the total reserves, nearly 88% are non-coking coal reserves, while tertiary coal's reserves account for a meager 0.5% and balance is coking coal. Indian coal is characterized by high ash content of up to 45% and low sulfur content. The Indian coal deposits are primarily concentrated in the Gondwana sediments, upper Paleozoic to Mesozoic systems, occurring in the eastern and central parts of peninsular India. The coal is of bituminous to subbituminous rank and is restricted to the sediments of Permian age. The tertiary coal-bearing sediments are found in the northeastern India, spreading over the states of Assam, Arunachal Pradesh, Nagaland and Meghalaya, of which the Assam coalfields are the prominent ones. A total of 298.914 billion tons of geological resources of coal have so far been estimated in India, up to the maximum depth of 1200 meters. Out of the total resources, the Gondwana coal fields account for 2,97,421 million tons, that is 99.5%, while the tertiary coal fields of Himalayan region contribute 1,493 million tons, that is 0.5% of coal resources. As of April 2013, prime coking coal contributes about 79% to the coal reserves of the country, with medium and semi-coking coal contributing about 16 and 5% respectively. The inventory of geological resources of Indian coal is prepared by the Geological Survey of India (GSI). Coal reserves in India, as per Indian Standard Practice ISP guidelines, ISP does not distinguish between resources and reserves, are classified under 3 categories: pro-with, indicated and inferred geological reserves. In Andhra Pradesh, important coal fields lie in the Pranhita Godavari Valley. In continuation of the Varda Valley, there are coal fields in the Pranhita Godavari valleys, covering an enormous area of over 9,000 square kilometers. The lower Gondwana rocks, consisting of Talcher, Barkar and Kamti, are well developed in the area. The exposures of Barkar rocks are few. The coal fields are traversed by post-Kamti faults. The characteristic of the coal fields is that these are devoid of igneous intrusions. Based on geographical and geological considerations, the Godavari Valley coalfield is divided into 12 coal belts. Out of 57 Gondwana and 14 tertiary coalfields considered for the national inventory of the coal, Orissa state has only 2 intact, geologically only 1.5 coalfields. Yet, its share in the reserve so far established in the country amounts to 23.6%. The famous coal-bearing basins are Ib River coalfields and Talcher coalfields, and as a sequel to which, these coalfields have been added advantage of being accorded most favored coalfields status by nature as far as quarryable potentiality is concerned. A substantial quarryable reserve has been located in northern part of Ib River coalfield, Gopalpur area, and towards its southeastern extremity in Kinda, Talabira area. Occurrence of coal seams have also been reported from Raniganj formation of Ib River coalfield very recently. The importance of Orissa coalfields is further enhanced due to their proximity to the east coast. About 1/5 of the estimated reserves of the country are located in coalfields of these states. Coalfields of these states are traditionally put into 4 groups: Central Indian coalfields, Singrauli, Suhagpur, Umaria and Johila; Satpura coalfields, Pench, Kanhan and Patekara; North Chhattisgarh coalfields, Chirimiri, Kurasia, Bisrampur, Jhilimili, Sonhat, Sendurghad, Tatapani, Ramkola; and South Chhattisgarh coalfields, Hasdo, Arand, Korba, Mand, Raigad. Madhya Pradesh and Chhattisgarh produce 29.2% of total production in India. Central Indian coalfields. Singrauli coalfield. This field is situated mostly on the border of Uttar Pradesh and Madhya Pradesh. While most of the field is in MP, a part of it is situated in the Mirzapur district of UP. In this coalfield, coals have been found in Barkar and Raniganj formation. There are 4 coal seams. These coals are useful for thermal power generation. Sohagpur coalfield. Sohagpur is another important coalfield in the Son Valley. Barmni-Chilpa fault trending east-west has divided this field into 2 parts. In the southern part of the fault, there are 5 coal seams within the Barkar formation. The coal contains 4 to 7% moisture and 20 to 27% ash. The coals on the north of this fault are characteristically different from the coals occurring south of the fault. Coking coals have been found in the north of the fault. Umaria coalfield. This coalfield is situated on the Umre river, a tributary of the Son river. The lower Gondwana rocks are well developed in this coalfield. 6 coal seams have been found in this field. The coals are relatively high in moisture, 7 to 10%, and high in ash, 18.6 to 29.4%. Johila coalfield. This coalfield is situated in the valley of Johila river. In this field, Talchirs, Barkars and beds of Raniganj age are developed. Johila seam is the most important seam in the northern area. The seam has a high moisture, 10.8%, ash 17.9% and volatile matter content 31.7%. Satpura coalfields. Satpura coalfields lie within the Pench, Kanhan, Tava valley south of Narmada river known as Satpura Gondwana basin. In this region, Gondwana lie in a syncline trending east-northeast to west-southwest. Important coalfields in this region are Mohpani coalfield. This coalfield is one of the country's oldest coal-bearing areas. It is situated in the west of Mohpani. In this coalfield, Talchir and Barkar formations are overlain by the upper Gondwana rocks of Bagra formation, Mahadeva group and Jabalpur formation. The coal seams in this area are weakly coking with moisture content ranging from 4 to 6%. Patakera coalfield. This is an important coalfield in the Tava valley. In the vicinity of Patakera, 3 coal seams have been encountered by boring. The top seam is of poor quality and the other seams are comparatively better in quality. Kanhan Valley coalfield. These are the most important coalfields of Satpura region. Coals of Kanhan Valley are characteristically coking, particularly in Damua, Kalichapar and Rahikol Koleres. The area is covered by Barkars. The area is intersected by number of faults. The coal in this region generally is of low moisture and ash content and is of coking quality. Pench Valley coalfield. This area is situated in the northwest of Chhindwara and lies in the east of Kanhan Valley coalfields. The rocks of Barkar formation are exposed in the area. Important coal seams are exposed in Gajando area, Barkuhi area, Chandamata, Dongar, Chikli area, etc. North Chhattisgarh coalfields. Tattapani Ramkola coalfield. This coalfield is located in the Surguja district of Chhattisgarh and covers an area of about 260 square kilometers. It consists of two separate areas, the eastern and western. The eastern portion is called Tattapani area, where 5 coal seams occur in the Barkar formation. The coals in the area are non-coking with low ash content. The western part or Ramkola area is separated from eastern part by a patch of upper Gondwana rocks called the Rajkhatra tract. There are 5 coal seams in the Barkar formation. The ash content varies between 17 and 34%. Jhilimili coalfield. This village is situated across village Jhilimili. The lower Gondwana is represented by Talchir and Barkar rocks. The Talchir rocks are exposed towards the south of the field. Barkar rocks, consisting of sandstone, shale and coal seams, mainly occupy the northern area. The coalfield may be divided into 3 areas: northern area, central area and southern area. In the southern area, good exposures of coals have been noted from several parts, out of which Manikmara is important. Sonhat coalfield. This coalfield lies west of the Jhilimili coalfield, forming the eastern extension of Sohagpur coalfield. The Barkar rocks which occupy the Sonhat plateau have been broadly divided into 3 divisions. The lower division consists of more than 15 coal seams. The middle division is devoid of coal seams. In the upper division, although Barkara strata is of considerable thickness in the field, the number of coal seams and their thickness is poor. Chirimiri area. 3 seams of the Karakkot horizon are the most important seams in this area. The composite seam is being worked in the collieries of Chirimiri, New Pauri, New Chirimiri and Kurasia. Kurasia area. In the eastern sector, drilling has proved the existence of workable coal horizon in this area. These are Duman seam, Kaperti seam, Shorgela seam and Kotmi seam. Bisrampur coalfield. This coalfield covers an area of about 1036 square kilometers. Coal-bearing Barkar rocks are developed to a thickness of about 150 meters. Several coal seams have been reported from different localities. In the southwestern part of the field, detailed prospecting conducted by Indian Bureau of Mines has indicated more than 1 horizon of coal. Pasang seam is the thickest seam in the horizon. The coal is of non-coking type in this seam. South Chhattisgarh coalfield. Hasdo, Rampur or Arand, Sarguja coalfield. This coalfield extends from Rampur and Paharbula La Pass in Arand Valley to Hasdo River in Bilaspur district. This coalfield is divided into 4 parts: the eastern or Rampur section in Rer, Arand Valley, north central Paharbula area, south central Aprora area, western or Matian area beyond the Gage and Hasdo rivers. The quality of coal in this field varies widely. The contents of moisture varies from 1.56 to 7.4% and ash from 11.26 to 25%. Korba coalfield. Korba coalfield is located in Korba district of Chhattisgarh and covers an area of about 530 square kilometers. The coalfield is named after the village Korba on the eastern bank of the Hasdo river, which is tributary of the Mahanadi river. The Barkar formation is the coal-bearing measures. As per GSI, a total of 10,075 million tons coal reserves available in Korba coalfield. The deposits are restricted into 2 distinct zones. Thick seam or quarriable power grade zone comprising of grade E, F and G having reserves of approximately 9,068 million tons. Thin seam or underground superior grade zones comprising of grade B to D having reserves of approximately 1,007 million tons. Mand Raigad coalfields. These coalfields are situated in Raigad district of Chhattisgarh and covers an area of about 520 square kilometers. This coalfield comprising of grades A to G and having reserves of 18,522.93 million tons. Here, large potential for power grade coal are present and may be exploited through open cast mining. Coalfields of Maharashtra. Coalfields of Nagpur region. Kamti coalfield. This coalfield is situated about 19 kilometers north-northeast of Nagpur. This coalfield can be called as a hidden coalfield as the coal-bearing rocks are not exposed anywhere. Later on, geophysical prospecting technique was applied in this coalfield for the first time for exploration of coal in India. Detailed exploration has proved a large deposit of coal in the following 3 blocks: Gatrohan area to the east of Kanhan River, Silevara area to the west of Kanhan River, Bina area to the south of the Kanhan River. 5 workable seams have been proved over the 3 blocks. The moisture content of the coals varies from 8 to 11% and the volatile matter from 33 to 43%. The coals are non-coking. Bukhara coalfield. This field is situated 9 km northwest of Nagpur railway station. 7 coal seams have been proved. The moisture content of the coal seams varies from 8 to 11% and the volatile matter from 24 to 29%. The coals are non-coking. Umrer coalfield. Umrer is a small town situated about 44 km southeast of Nagpur. The coal-bearing strata is nowhere exposed at the surface. The coal-bearing Barkars rocks lie over talchers. There are 4 workable seams in the area. Varda Valley coalfields. The Varda Valley coalfields are situated in the valley of Varda river, lying mainly in the Chandrapur district. The coalfields extend in a northwest-southeast direction, extending over a distance of 115 km and cover an area of about 4,130 square km. The coal-bearing Barkar rocks are only 76 meters thick and occur in patches. Rarely, coals are found in the outcrop. Coalfields of Andhra Pradesh. In Andhra Pradesh, important coalfields lie in the Pranhita Godavari Valley. In continuation of the Varda Valley, there are coalfields in the Pranhita Godavari valleys covering an enormous area of over 9,000 square kilometers. The lower Gondwana rocks consisting of Talcher, Barkar and Kamti are well developed in the area. The exposures of Barkar rocks are few. The coalfields are traversed by post-Kamti faults. The characteristic of the coalfields is that these are devoid of igneous intrusions. Based on geographical and geological considerations, the Godavari Valley coalfield is divided into 12 coal belts. Ramagundam coal belt is one of such coal belts located along the western margin of the Godavari Valley coalfield. Important coalfields of the area: Tandur coalfield, North Godavari and South Godavari coalfield, Karlapalli or Kamaram coalfield, Ramagundam coalfield, etc. Coalfields of Orissa. Out of 57 Gondwana and 14 tertiary coalfields considered for the national inventory of the coal, Orissa state has only 2 intact, geologically only 1.5 coalfields. Yet, its share in the reserve so far established in the country amounts to 23.6%. The famous coal-bearing basins are Ib River coalfields and Talcher coalfields, and as a sequel to which, these coalfields have been added advantage of being accorded most favored coalfields status by nature as far as quarryable potentiality is concerned. A substantial quarryable reserve has been located in northern part of Ib River coalfield, Gopalpur area, and towards its southeastern extremity in Kinda, Talabira area. Occurrence of coal seams have also been reported from Raniganj formation of Ib River coalfield very recently. The importance of Orissa coalfields is further enhanced due to their proximity to the east coast. Gondwana coals occur in India mainly along the 3 master Gondwana basins, that is Damodar Valley, Son Mahanadi Valley and Gondwana Valley. Coalfields of Orissa constitute the southern part of the Son Mahanadi Valley basin. Except the Ib River coalfield and Talcher coalfield, there are 4 more Gondwana basins in Orissa: Athaghad Basin, Jai Silat Basin, Athamalik Basin, Katranjia Basin. Upper Gondwana coals. It includes coalfields of Gujarat. Subbituminous type of coal is found in association with Upper Gondwana sediments, Cretaceous, in the district of Kutch, Surendranagar and Mehsana district. Tertiary coals. Essentially, the coal deposits of commercial importance are mined in the states of Meghalaya, Assam, Arunachal Pradesh and Nagaland. Meghalaya. The coal deposits of Meghalaya occur within a narrow belt extended from the Garo Hills in the west, through the Khasi Hills in the middle, to the Jaintia Hills in the east, and range in age between Paleocene and Eocene. The Sylhet limestone formation, especially its Lakadong sandstone, is the principal coal-bearing horizon in Garo, Khasi and Jainia hills. The volatile matter and carbon contents of the coal vary between 38.2 and 52.5% and 76.4 and 85% respectively. Based on vitrinite reflectance, the rank of these coals has been described to be subbituminous to high volatile bituminous. Assam and Arunachal Pradesh. The tertiary coal deposits of Assam and Arunachal Pradesh occur within a long narrow belt trending northeast-southwest, ranging in age between Upper Eocene to Oligocene. These coal deposits are understood to have originated in the foreland basins, especially in the zone of Chupin. Coal deposits are found in the Barail group. The coal-bearing barails are divided into three formations. The different coal-bearing patches are Desai Valley Coalfield, Janji Valley Coalfield, Nazira Coalfield, Safari Valley Coalfield, Jaipur Coalfield, Makum Coalfield, Namchik Namphuk Coalfield. The thicker economically viable seams are particularly confined to the Nazira, Jaipur, Makum and Namchik Namphuk coalfields. In the coals of Assam and Arunachal Pradesh, the volatile matter and carbon contents range from 43.9 to 51.9 and 75.8 to 82.6 respectively. Nagaland. Borjan coalfield is the most important coalfield of Nagaland. This coalfield is situated in Nagaland about 18 kilometers south-southeast of Nazira, which is in Assam. The coal of this coalfield was widely known as Nazira coal. The coalfield is along the steep slopes of the western flanks of the Naga Hills. Coal seams occur in the Tikak Parbat formation of Barail group of Oligocene age. Two persistent seams occur as the lower and upper membranes of the Tikak Parbat formation. The coals of the Borjan coalfield contain moisture from 4.9 to 5.2% and ash from 1.6 to 3%. The coals are weakly coking. Jammu. The coal-bearing horizons of Jammu are mostly confined to the basal part of the Eocene bed, constituting a part of highly folded sub-Himalayan orogenic belt along west-northwest, east-southeast trend. The coal measures belonging to lower Subhatu group, lower Eocene, occur along two linear zones. Uneconomic Danswal. Sawalkot and other coal fields along southern margin of Pir Panjal range, and a chain of economic coal inliers comprising the important coal fields like Kura, Kalakot, Metka, Mahogala and Chakkar, stretching roughly along northwest-southeast to the further south of Pir Panaji range. Jammu coals are in general low in moisture, 0.7 to 2.1%, and volatile matter 9.3 to 19.1%, with highly variable ash content 9.7 to 45.7%. Gujarat. ONGC, while drilling for oil, has come across a large reserve of coal, about 63 billion tons at a depth ranging from 700 to 1700 meter in Kalol Mehsana district in Gujarat. The coal associated with shales, clay stone and sand occurs in Kalol formation. Coal associated with shale and sand also occurs in Kadi formation. Both the formations are of Eocene age. Lignite deposits of India. Large deposits of lignite are found in many countries like Germany, Australia, USSR, USA, China, Canada, Italy, Turkey, etc. In India, the utilization of lignites in various industries and power generation are gaining importance. In comparison to coal, it is low in ash and sulfur content and also creates less environmental hazards. Presently, the contribution of lignites is about 4% of the energy needs of our country. The occurrence of lignites in India is known in Tamil Nadu, Neyveli, Pondicherry, Bahur, Karnataka, Udupi, Andhra, Ellur, Rajamundry, Maharashtra, Ratnagiri, Gujarat, Panandro, Akrimota, etc. Rajasthan, Palana, Gurha, Kapurdi, etc. and Jammu and Kashmir, Nichahom. In India, Neyveli Lignite open cast mine of Tamil Nadu is the largest mechanical mine, producing 24 million tons of lignite annually and generating power with installed capacity of 2490 megawatts.